So Wes, I see we want to talk a little bit about data compression and what we do with Storage Foundation, right?
That's right.
Okay, go to it.
So data compression is relatively new in Veritas file system. And we probably deal with it on a daily basis. We have regular compression tools in our daily lives that we use. And this one's built into Veritas file system. And essentially I want to talk about what the basics of compression are. So if we take a file, just a standard everyday file that has strings of data in it. So I'm going to just put some common strings and stuff in here. So 1, 2, 3, 4, 5, 6, 5, 3, 2, 1, 1, 2, 3, 4, 5, 3, 3, 2, 9, 0, 1, 2, 3, 4, 5. So basic compression algorithm, and they all basically do this the same. They go through and look for common strings. So as we're going through this, we see this matches this and matches this. So what the algorithm is going to do as it encounters duplicate strings of data is essentially erase one of the duplications, put a marker file that points to a duplicate. And we hit this one, we see it, we delete it, we hit this one, we erase that, put a marker in there, and it's going to point to the same piece. We just do this. And the more strings that match, the better the compression, because we're saving all of this space right here. Now, when we uncompress a file, essentially we're taking this data and copying it back into the places where the markers are. So we use the same amount of space after an uncompression as we had before the compression. So that's essentially the basics. Now, some important notes about our compression is it's not inline, meaning you create a file, it's not automatically compressed. It's always compressed on demand. So an important thing to note for that is when we have a file that's laid out on disk, okay, so here's my file on disk, boom, goes to a certain point. When we compress this, as we find these common strings, and then we can save space, we're actually going to a smaller amount of space, and we're saving it. Depending on the file, we can save a considerable amount of space. Well, the space that we are using for this is going to be broken up into block sizes. The block sizes can be set with our compression utilities. The default is 1 megabyte. Okay? We call this a compression chunk size. It's also setting the size of an extent for the file system. Okay? When we read data that is from a compressed file, when we're reading it, that data that is in that extent or this chunk is loaded into memory and uncompressed there. The data block on disk still remains compressed. If we do a write operation to any of these extents within this file, the data block is loaded into memory, uncompressed, and when we do the write, it goes back to the disk uncompressed. And it will remain uncompressed unless you compress it again. Okay? We do support multiple algorithms, but the only one that's currently available is gzip. And we have strengths of 1 through 9, 9 being the best compression, 1 being the fastest compression, but not the best. Okay? The default is 6, so we get a nice ratio between those. And basically the last thing is performance orientation. Bringing a block into memory for a write operation or a read operation and the uncompressed process takes time. You don't want to compress files that are going to be frequently accessed for reads or writes. Okay? And
so that's pretty much what we have to think about. Is that it?
That's pretty much it.
Fantastic. So what I see here is how we can basically explain compression to a customer, how it really works. And this is all part of the Veritas file system, which is part of Storage Foundation. So Wes, thanks for taking us through the basics of the data compression.